Reynolds. Friction factor means F. And what is the loss? Means this. What information do you have? Temperature, length of the pipe, diameter of the pipe. That's a pretty large pipe. And that's commercial steel, new. And what else? This one. Look at the unit. The unit says liter per second. Liter is a kind of volume. Second, time. So if you divide these two, that's your discharge. So in case that you said, okay, what's the flow is? What the flow is here, it's discharge, which I'm going to write it like this guy. So if you are going to change liter per second to cubic meter per second, you just need to divide your data by 1000. And when it talk about material of the pipe, it means that you have a table that you can read the what's that? Read the roughness. You have two kind of commercial steel. It says new, so I will pick that one. And we have millimeter and feet. So for sure, I will go for the millimeter because everything here is SI. So let's start to find maybe Reynolds first, then F. Reynolds. I remember I wrote the steps. I want to write the same for you. This is Reynolds, right? V over nu. So you don't have velocity. So previous, you should find velocity here. Or maybe I should write it like that. Yeah, better. And before that, you can find E over D because you need it. Find F and find HF. So let's start with this guy. 0.045 multiplied by this guy divided by 1.5. I think I have the answer here. Where is that? Yeah. Be careful about the number of zeros that may cause trouble for you. This one, 3.5 divided by pi multiplied by 1.5 squared, 4, which gives me 1.98 meter per second. Now Reynolds. Velocity 1.98, diameter this. About nu, or if you are using rho VD divided by mu, be careful. You don't have the data, but you have the temperature. So if you go for the temperature, you will find this number. Or you can just consider something close to that, which is fine. And the Reynolds is 2.97 multiplied by 10 power to 6. For F, you have Reynolds, you have E over D. So, Moody. I like the name, Moody. Okay, back to this one. Here we go. If you remember, E over D was 0.000, so many zeros, 3. So 4 zeros here, 4 zeros here. One of them 1, the other one 5. So 3 should be somewhere here. So make a line here. Reynolds is 2.97. Let's say 3 multiplied by 10.6. 10 power to 6. 10 power to 6 is here. That's 2. That's probably... Am I right? Sorry, that's 1. That's 2, that's probably 3 here. Or no, 3 is here. Sorry, 3 is here. Yeah, that's hidden here. And make a line here. And if you look, it is something like that. So make the line. It's very close to a smooth pipe, if you notice. I don't know why, but here we go. And I will join it here. So, or even a bit, sorry, higher. It shouldn't be here. Like something here, a bit higher. So let me go back or maybe erase that. I don't want to cause trouble for you. Here we go. 1 is here, 2 is here, 3 is here. So that's 3. 3 is here again. So here we go. And yeah, that's here. So if you go, it's somewhere here, seems. Am I right? 3 is here. 5, yeah, here. So I'm going to make like imaginary line cross here. If I do that, that's probably a number. The one that I have is a bit lower, but yeah, I can say F is equal to this guy. Where was my solution? Here. So F is 0.01 or 1, the one that I have. So the second part is done, the first part is done. Let's go to this part. The easiest part because you have everything. F, you have it. L, I said 500 meter. D 1.5 velocity, you have it. 2 multiplied by the 8, which will lead you to have this high of water of loss.